Are you a student struggling to keep up with your lessons? Or a parent searching for a reliable educational resource that truly cares? You've come to the right place. Welcome to FEUNIX Distinctions, your premier channel for educational content designed for every learner. We understand the silent struggles that often go unnoticed, the frustration of slow-paced learners, and the need for solid foundations for all students. At FEUNIX Distinctions, we don't just teach. We are dedicated to guiding you every step of the way. Our teaching style is unique, simple, and incredibly effective. We make complex concepts easy to grasp and ensure that every lesson is both suitable and enjoyable, no matter your learning pace. Whether you're a fast learner looking for a new challenge or an average learner aiming to excel, our comprehensive methodology is built to support you. Join a community where no one is left behind. Subscribe to FEUNIX Distinctions today and hit the notification bell so you never miss a lesson. Let's make learning an exciting journey together.
I welcome you all to this very class, JSS2 class. This is JSS2 Mathematics and we're moving on to lesson 7. And our topic is indices. This is a new topic. We're going to be seeing this topic, indices. Please take these topics with all seriousness, and this topic will keep appearing even in your senior class. We are going to be looking at laws of indices. Laws of indices. We will not waste time. In indices, the first one is multiplication law. Multiplication law. The second one is division law. Let me say something about the multiplication law. Multiplication law says that if you have any number and that number is the same, I'm just using this later to tell you about the number. I'm going to use a real number, but let me just use later to show you what I'm trying to say about the law. Then we'll use a number for it. X and X means the same number. If you have the same number and those numbers are multiplying themselves, those numbers will be having power. Let's say the power of this very one is A and the power of this second one is B. This is what you will do. Since the numbers are the same, this X and X are the same, so long as they are the same, just pick one of them. Then the powers, even if they are not the same or they are the same, it doesn't mean. What you will do to the powers, you add them. You add the powers. Why are we adding the powers? Because this place is multiplication. That is why we call it multiplication law. If you are multiplying numbers that are the same, pick one of them and add the power if you are multiplying. But if you are dividing them, if it is division, you do the same thing. You pick one of them, but for the powers, you subtract the powers. So that gives rise to law number 2, which is division law. Division law. In division law, if you have X and X, and okay, this is division, please. X divided by X, and we have the power A and B. What do? We pick one of them since they are the same, and then we subtract the powers. In division, we subtract. Let me give example. Example 1. Simplify 10 raised to the power of 2 times 10 raised to the power of 3. So what can we see here? This 10 and this 10, they are the same. Since they are the same, you pick one of them. Since this place is times, you will plus the powers. 2 plus 3. That makes it 10 raised to the power of 5. Right? So This is 10 raised to the power of 5. Example 2. Simplify 10 raised to the power of 2 divided by 10 raised to the power of 3. I want to make use of law 2, which is division. We said if the bases are the same, you kindly pick one of the bases. If it is division, then you pick the first power minus the second power. That is 10 raised to the power of 2 minus 3 is minus 1. So that is what the first and the second law is talking about. So we have it here, multiplication law, division law. We have a third law here. The third law is called power zero. Power zero. This law says anything raised to the power of 0 is 1. It could be a letter, it could be a number. Doesn't matter how big the number is, doesn't matter how small it is. So long as it's raised to the power of 0, it's 1. Okay, for example, x raised to the power of 0 is what? Is 1. Let me use a number. 25 raised to the power of 0 is 1. 18 raised to the power of 0 is 1. That's the third law. We're going to make use of everything. Let me add one more, the fourth one. Negative power. Negative power. If we have something like this, x raised to the power of minus a. This is the negative power here. See, this power is negative. So what are we going to do? The negative will become 1 all over. So we have 1 all over x raised to the power of a. This power a is here, but the negative that is there, this very negative, is the one that becomes 1 all over. When you have a negative power, the negative becomes 1 all over. So you will not see the minus here again because the minus have become 1 all over. And then this x is there. And then this a is also there. So let me write it. Let me use a number now. We have a number like this, 3 raised to the power of minus 2. What are we going to write here? It will be 1 all over 3 raised to the power of 2. The minus that is here have become 1 all over. So we can continue with this work. That will be 1 all over 3 raised to the power of 2 means 3 in 2 places. 3 in 2 places. That is 1 all over 3 times 3 is 9. That is 1 over 9. That's the answer. We are going to solve more example. Simplify the following. 1. Ten raised to the power of minus 2 times 10 raised to the power of minus 5. Let's do this. This will be 10 raised to the power of minus 2 plus minus 5. Where did we get this plus from? These times. You say when the bases are the same, pick one of them. And then if this place is times, you plus the power. So this is the first power, which is minus 2. This times is what gave us this plus, and this is the second power, which is here. Let's move on. This will be 10 raised to the power of minus 2 minus 5. Anywhere you have plus and minus in the same place is minus. This will be equal to 10 raised to the power of minus 2 minus 5 from number line. That will be minus 7. And if you want to move further, that is if you want to use negative power law, that's the fourth one. This power that is negative, the negative can become 1 all over. So we can write this as 1 all over 10 raised to the power of 7. Let's solve another example. Example 2. Simplify 10 raised to the power of minus 2 divided by 10 raised to the power of minus 5. I still want to use the same figure. This time around, division. What are we going to do? We'll pick one of these since they are the same. Then this is minus 2. Because of this division, that will be minus. Then this is the next power, which is minus 5. So you see we have 2 minus here. We got this one from the division. And then the second one is from the power here, which is minus 5. This will be equals to 10 raised to the power of minus 2 plus 5. Minus and minus in the same place is plus. Minus and minus in the same place is plus. So let's move on. This will be 10 raised to the power of minus 2 plus 5 is plus 3. Is plus 3. If you have problem with number line, you chat me up on WhatsApp so that I can create time for you and explain how minus 2 plus 5 becomes 3. So at this point, 10 raised to the power of 3, if you like, you can move further to express it as 10 in 3 places. That's the meaning of 10 raised to the power of 3. 10 times 10 times 10. That is 1000. Let's solve another example. Example 3. Simplify 22n raised to the power of 7 divided by 2n raised to the power of 3. And when you look at this, you see that this number and this number are not the same. This is the only number that is the same, this one and this one. So this number and this number that are not the same, they will do their normal division. Normal division. That is this 22 divided by 2. That is this 22 divide by 2. Then this n, look at it, n raised to the power of 7 divided by n raised to the power of 3. This one can go on with the law 2, because the bases are the same. But for this one, the bases are not the same, so they have to do their own normal division. Which of course, 2 here 1, 2 here is 11. This one gives us 11. Then you pick one of these n since they are the same, and then you will subtract the powers. 7 minus 3. Why are you subtracting? Because it's division. Once you have division, you subtract the powers. Pick one of the bases that is the same and subtract the powers. This is now 11n raised to the power of 4. That's our answer. If we're not tired, we will solve another example. Example 4. r times r raised to the power of 0 times r raised to the power of minus 5. Yes, all the bases are the same. In fact, I can solve this in two different ways. All the bases are the same, so I can pick one of the bases. Since it is times, I can plus the powers. Let me start plussing the power. What's the power here? If nothing is written, it is 1. Like this r now, the power nothing is written. So if nothing is written, it's 1. Plus, what's the power here? 0. Plus, what's the power here? Minus 5. This will be r raised to the power of 1 plus 0. Anything plus 0 is that thing. 1 plus 0 is 1. And this is plus and minus. Anytime there is plus and minus in the same place is minus. Minus 5. This is r raised to the power of 1 minus 5 is minus 4. And if we want to make use of the negative power, that is the fourth law, this minus can become 1 all over. So we can write this as 1 all over r raised to the power of 4. Let me write it again. 1 all over r raised to the power of 4. That's the answer. We have solved enough examples. I will leave you with some questions to try. Solve these questions as assignment. Simplify the following. One. 10 raised to the power of minus 2. Question number 2. 10 raised to the power of minus 4. Question number 3. X raised to the power of 5 times x raised to the power of minus 2. Question number 4. A raised to the power of minus 2 times a raised to the power of minus 3. Question number 5. M raised to the power of 0 times n raised to the power of 0. Please take note of this. I'm tempted to help you. M raised to the power of 0 is 1 times n raised to the power of 0 is also 1. 1 times 1 is 1. Okay. Because I don't want you to say that the bases are not the same. Anything raised to the power of 0 is 1. So the whole of this is giving us 1. All of this is giving us 1. 1 times 1 is 1. Anyways, let's continue with the assignment. A raised to the power of 2 divided by a raised to the power of 7. Question number 7. C raised to the power of minus 1 times c raised to the power of minus 1. Question number 8. Open bracket 1 over 2 raised to the power of minus 2. We are going to stop here. Please don't forget to click the subscription button. So click like and click share. It's very necessary. It will help to send you a reminder when a new video is being posted. Thank you and have a nice day.